Alright, hi, so we are Innov8 and today we'll be talking about CAD, computer-aided design, and what we've learned about both SolidWorks and Onshape. This is our team. We are an all-girls team from Cincinnati, Ohio, and this will be our 4th season. And this summer, virtually, we learned about CAD through both SolidWorks and Onshape. CAD is important for a few different reasons. First, it can help you design and 3D print custom parts to improve the function of your robot. For example, last year we had a lift, so we printed out custom brackets for the lift. You can also save time by designing your robot and being able to see how the parts will fit together before you actually start to build. So that can help with just the planning aspect of things. And then lastly, CAD is a real-world skill that can be used in many industries, so it could be really helpful to learn it now. SolidWorks and Onshape, which are two CAD tools, have a few differences. So SolidWorks is compatible with only Windows as an app, and it does require a license, but as an FTC team, you can contact SolidWorks and get an educational license for free. And then Onshape, on the other hand, is just a website, and it's also an app. It's compatible with pretty much all devices.
We are going to be giving a brief overview of the 3 uses of SolidWorks. SolidWorks part function allows you to make a custom part from scratch. You have to start from a plane. The planes determine the direction you will need to extrude your sketch. There are numerous tools you can use. Most of the sketch tools are shape-based, but you can also make your own plane and add text. Once you create your sketch and define your measurements with the Smart Dimension tool, you can use tools to make your part come to life. Extrude Boss Base will add dimension. Extrude Cut will cut into a part through a selected surface. Fillet will round selected edges, and Shell will hollow out the part. As you gain experience with the software, these tools will become much more familiar. Next, the assembly function is used to group parts together. You can either use your custom parts you've made or import them from sites such as Rev Robotics and Andy Marks. Basically a site that allows you to import the part you need. The file imports are under the name CAD, and there you download the link. There are more mates that are shown, but these are some of the most common ones. These mates are coincident, which requires the selected surfaces to touch. A parallel exists on parallel planes. A tangent mates a rounded or curved point. Centric aligns concentric features, often circles or ovals. A lock mate secures a part or point in its current location. Finally, the distant mate locks a point a given distance away from another. Once the assembly is fully defined, which means the parts can no longer move, check the bottom right-hand corner. The assembly is then completed unless more parts are added. For the drawing function of SolidWorks, you can either insert a part into a drawing or make a drawing from a part. I have found it easier to do that later, but it is a personal preference. The program will provide different views of the part to insert into the drawing. In addition to having different views of the part on the template, it is important to add measurements as drawings are often used as a reference. A good side note is that a useful tool to know about is the detail view, which provides a magnification effect. Moving on, we have compiled some tips we have learned from our experience with SolidWorks. In the bottom right-hand corner, there is a menu that says IPS. Click IPS to change the document's measurement system. For example, it can be measured in inches, millimeters, or centimeters. Also keep in mind that SolidWorks has a measuring tool. This tool can be useful for determining measurements for a custom tool or simply double-checking measurements. Our SolidWorks tip is to make sure your part or assembly is fully defined. An undefined measurement means the system is lacking data about your sketch or assembly. A defined sketch would be black instead of blue, and a defined assembly will be read fully defined in the bottom left-hand corner. Additionally, in case you need more information, here are some resources. First, there is the official SolidWorks tutorials. We have been going through the tutorials. They are very helpful to learn basic ideas and put those ideas into practice. These tutorials tend to go over general ideas, so if you are looking for help over a specific concept, it may be more effective to search Google or YouTube.
If you shift over to Onshape, You will see that many of its features are very similar to SolidWorks, making it an easy transition from one to the other. You are also able to import parts or assemblies from SolidWorks to Onshape with the use of STL files. When you start in Onshape by opening a new document, this is what the workspace will look like. As you begin to build your parts or assemblies, the program will automatically save your work. Another huge benefit to working on Onshape is that multiple people are able to work on the document simultaneously. This is Part Studio. To begin making a part, click on the sketch, then choose the face you want to make yours on. Choose a shape and then click drag to draw it. Next, choose the Extrude button, choose the sketch, and choose whether you want to extrude or remove the sketch. Continue to do this until you are satisfied with your part. In the Assembly workspace, you are able to import any parts or assemblies that you have made as well as any that you have downloaded. This allows you to find downloadable parts online, such as Rev or Tetrix parts, that you can import into our document and use to create an assembly, as you can see in the assembly above, which includes several Rev Robotics pieces that we downloaded from the Rev Robotics site. Then we used mates that are similar to those in SolidWorks to assemble a model of a robot's base. If you need to alter a certain piece, such as cutting it, you can first use Part Studio to make the changes before importing it into the assembly. Mates can be used to put two parts together or make them move in a certain way with each other, depending on the mate you use. Fasten mate is one of the mates, and it is used to stick two parts together. Revolute mate makes the two parts move on the same axis when you move one. Planar mate puts both the parts on the same plane. For more description, you can hover over the icons, and there are plenty more mates besides these three. If the mate is not in the exact place you want it, just click on the offset button while you are still on the mate and move it on the X, Y, and Z axes. There are also relations to use for the common parts, such as gears, rack and pinion, screw, and linear relations. These make the two parts move in the way these parts would move in real life. If you were to move them in the CAD program, which makes them very helpful feature in comparison to SolidWorks. Next, we have the 2D drawing. You can use this to make a drawing of your part or assembly, using different dimensions and views of different faces. To make a drawing, open your part or assembly. Click on the plus sign in the bottom left corner, then click on Create Drawing. After that, choose a template and begin inserting views. You'll have many view options, such as front, top, bottom, and side. The image in the bottom right shows a finished drawing. Onshape also has a lot of resources to help users learn how to use it. Once you make an account, you can access the Learning Center, shown above, which gives you access to classes and tutorial videos. There are some classes that you have to pay for, but there are still plenty of free resources too. You can also find tutorial videos for Onshape on YouTube.
So over the summer, we worked on a couple of projects to help us practice CAD. The first one was these name tags, which we made using the Part feature of SolidWorks or Part Studio in Onshape. As you can see, the front says our name, our team name, and our team number, and it has small holes for LED lights. The back is a little harder to see on these pictures, but it has little channels for circuitry and a spot for a battery and a switch. After we finished designing them, we printed out the name tags and then attached all the electronics. We're also currently in the process of modeling our robot from last year in SolidWorks and Onshape. We have been recreating small parts of the robot, like the base and wheels or the capstone dropper, and then when we're done, we'll put it all together in one assembly. For projects like that, you will want to be able to find CAD files of the parts you use to make your robot. Fortunately, most part companies make the CAD files of their parts available online, so it's easy to download them. You just need to find the part you want on a company's online store, download the file, and then import it into whatever program you're using. The link on this slide goes to a Google Drive folder that also has a lot of downloadable Rev parts, and we'll send out this slideshow so you can use that link if you'd like. Another useful tool for CAD projects is GrabCAD. GrabCAD is a website we use that's really helpful for CAD-related stuff. The main feature we use is called GrabCAD Workbench, and it's basically like GitHub for CAD files. It allows you to share files easily, and it keeps track of different versions. So if you make a change that you don't like, you can revert it back to the original. This is really helpful for organizing CAD parts and files. GrabCAD Community also has other cool features, like a library of free 3D designs that you can download and tutorials made by other CAD users. You should definitely check it out if you're interested in CAD. Thank you guys for watching this presentation. Next, we're going to show you some quick tutorials using the actual software, and then we'll answer any questions that you have.
Hello, today we'll be showing you how to create a part. So we will be showing you some of the basic features that we have. So first we'll start with a sketch. And when you hit sketch, you will be shown different planes. So in our part, it doesn't really matter which plane we'll be using, but just keep in mind that these will be showing different faces when you create your part. So for now, we'll hit the front plane, and we want to create a square. Up in the left-hand corner, there is some icons such as a square, a circle, an oval. For this, we'll be using the square icon. And we're going to be hit center rectangle, which will create a rectangle from the origin. And for now, you can just hit anywhere, because then we will go into a smart dimension, which will allow us to create our desired dimensions. For this, we can make it 2.5. And also doing this, it will fully define our sketch, which you can see in the bottom right-hand corner. Now we want to make this sketch from a 2D view to a 3D view. So here we will hit extrude boss base, and it will extrude our sketch. So we can just keep it at this depth, which is 2.5, and just hit the green check mark. Now we want to create a hole in the center of this square. To do that, we'll hit sketch, and then click on a face, so the front face, and then we can hit circle icon, and then we can just rotate ourselves to see the origin. And then we can also do a smart dimension that will allow us to define our sketch. Now to create this into a hole, we're going to go back to the Features tab and hit Extrude Cut. So here you can see that it's showing you an arrow through the center of your rectangle or square, and this shows you which direction it will be cutting. So we have selected blind, which just is basically how we want to cut it, but there's also options such as through all, which just will cut through the entire part. Then there's up to next, so you could say up to the next surface, and then up to vertex. So there's really different options, but for now we'll just stick to blind. And it's 2.5, which is our depth, and just hit the green check mark. And now you have created a hole into your part. Before we go into assembly, we will show you how to fillet the edges. And this fillet feature just rounds the edges of your part. So here we will be hitting the square's edges, And then once you hit these, you can decide your radius, which basically shows you how big you want the edge rounded to be. So ours is 0.1, which is a good size. And here you can just see it has rounded the edges. Now we'll be moving on to an assembly. So for this assembly, our goal is to align these two parts. We'll be showing you some of the mates that we use to align these. So we'll click mate. And here you'll see some mates such as coincident, perpendicular, lock, and the distant mate and concentric mates. So you just choose whatever one is the best for your assembly. So since we want these to align, we'll be using coincident mate. And now you have it aligned. And when you drag one piece, the other piece should follow and not move. So that is what our piece currently looks like. Now the next mate we'll be using is a concentric mate. So a concentric mate is just used to align concentric features, such as what we have a hole. And this just is a bit easier than trying to coincident all the sides and edges. It just aligns these pieces with their hole. So you just hit concentric and then you'll just hit the circles and there is a concentric. Now, say you want to not make it move, you should probably just coincident these since it'll make it aligned. And then if you do want to stop it from rotating, you can just continue to mate the sides together so that they will stay in place. And you can see that once it is like this, it is fully defined. Now the next mate we'll be using is called a distance mate. This just puts these two at a designated distance that you would like. Say we want these pieces to be aligned, but we don't want them to be touching. So we can just use the distance mate to align them, but make sure that they aren't touching in case we want something to go in between them. So we can distance them like an inch apart. And that they do stay 1 inch apart. And as she's trying to drag these pieces, they don't drag because they are fully defined.
Okay, so I'm going to be explaining about making an assembly in Onshape. This is an example of an assembly we've built. You could definitely make it more complicated and add parts, but this one was just something simple. So if you want to build your robot in Onshape, you're going to need the parts. So I'm just going to show you how you can import those into Onshape. So for that, you first want to go to the website and find the part that you want. I chose this extrusion from the Rev Robotics website. And then you basically need to look for the file that you can download. It's in the description normally for Rev. And then you just need to click on that and download it. And then go back to Onshape. Then in Onshape, you want to hit Create, and then Import File, and then choose the file that you just downloaded. And then you can choose which one you want depending on what you're trying to do with the part. So it just imported it into a single document. And then it'll just load. And then it normally pops up as the first document. and then you can open that. And you now have your part imported into Onshape. Alright, now I'm going to show you how to make two pieces together. I'm just going to show you an easy example, and this is how you could mate all your parts of your robot, for example. And a mate basically fastens two pieces together, so if you move one of them, the other would move in a certain way with it. So fasten mate is what I like to use. This will fasten the two parts that you select directly to each other. And if you hover over each mate, it'll give you a little description of how to use the mate and what it does. Besides fasten, there's a couple other mates you could use, and they each have a different function, so if you're trying to decide which one you want to use, I would read the description and then decide if it makes sense to use for whatever you happen to be mating. And here you can see I'm hovering over some of the other mates. To mate this axle to the axle hub, I'm going to use a fasten mate. So to do that, I first click on fasten mate, and then you need to choose the two parts that you want to mate together. So in this example, I'm going to choose two faces. So I'm choosing this face of the hexagon of the hub, and you want to make sure that the blue line is pointing upwards when you want to mate two faces directly to each other. So I'm choosing the top one, and then I'm choosing the top face of the axle as well, so the very top of the hexagon. And then with that, I also am making sure that the blue line is pointing upwards. So when I mated those two together, the hub moved to a spot where I didn't want it. So to do that, I'm going to offset it and then adjust the correct axis. So in this example, I needed to change the Y. You might have to adjust how much you offset something until you get it exactly where you want it. So that was good, so I hit the check mark, and then that mate was done. Since that mate is done, now if I click and drag to move the object, all the parts move together. Now I'm going to show you another way that you can use the fasten mate. So in this example, I'm going to be mating the two brackets on either side of the axle to the two extrusions that line up with those. And I'm going to use fasten mate again because it makes the most sense to use it, and it's pretty simple. So I chose which mate I wanted, and then I went to the underside of the bracket, and I'm choosing a face again, so I made sure that the blue line was pointing upwards. And then since I want this to be mated to the top of the extrusion, I have to go back to the correct side, and then I'm choosing the very middle face of that extrusion. And then just like for the bracket, I had to make sure that the blue line was pointing upwards. When I selected the face of the extrusion, the mate formed in a spot where I didn't want it. So to adjust the mate, I offset it, and this just lets you adjust the axes of the mate. So I adjusted the X and the Z, and once I did that, it was all good. So that mate was done. For the other bracket, I followed the same process of using a fasten mate, and then something helpful is since I couldn't get to that bottom side of the bracket, I hid the extrusion, which if you go to the left side with the list of instances, you have the option to hide parts. So I did that, and then I was able to select the part of the bracket, and then you can see I unhid the extrusion, so it came back so I could select it for the mate. When everything was good, I hit the check mark again, and then that mate was set. And that's it about making assemblies.
We are going to be creating a simple name tag today with some words, a fillet, and a hole for the lanyard. First, we're going to create and then a document. We're going to name the document name tag. And we're going to create the public document. We'll be using Part Studio to make this name tag, and this is what it looks like. There are two tabs that pop up, Part Studio and Assembly. We're going to be using Part Studio. And in the top right hand corner there's a cube. That's where you're going to be looking. We're going to be looking at the top. So first you're going to sketch, and when you click sketch, you're going to select a plane. We're going to select the top plane, We're going to make a rectangle. There's a choice between center and corner. We're going to choose center for today. So you click the center point and you click the corner point. Now we're going to use the dimension button to make the sizes we want. So we're going to make this 4, and we're going to make this length 3. Next, we're going to click the green check mark and we're going to extrude the piece. So click the extrude button and click the piece. You should be on U for this part, and then for depth, put 0.5. Now you can see that it is a 3D shape with a height of 0.5. Next, we're going to sketch, but this time the plane we're choosing is the front face of the name tag. And we're not going to be using the shapes, we're going to be using a text. So click on the text box and make the text box. And you're going to choose what text you want. I'm going to put Innov8 name tag. Now I can format it however I want. I can even choose the different font that I want to make it bold and to flip it. I'm going to click the check again. And as you can see, it came out a lot bigger than we needed. So we need to dimension it. Click the dimension and click the side that you want to dimension. We're going to do 3.5 for the width. Now as you can see, it's not in line. So we're going to go onto the drop down menu next to dimension, and you can see a horizontal and vertical button. Those will align them horizontally and vertically. First, we're going to click horizontal, and we'll click the 2 points we want to use. Then they'll align it horizontally. Next, we'll do the same thing with vertical for the same 2 points. And that's where I want it. Next, you can unclick the vertical button and then click the green check mark. We're going to now extrude the text, but this time we're not going to add, we're going to remove. We're going to make it with a depth of 0.25, so that it doesn't cut all the way through, but only part way. As you can see, there's a depth to it now. Next, we're going to add a fillet. A fillet, it makes the edges round. I'm going to click that button, and then click the edges we want to fillet. As you can see, it rounds them. Now, I don't really like the size of this radius and how much it's curling, so we're going to do 0.1 for the radius, and we're going to click the check. That's how I like it. Finally, we're going to add a hole for the keychain or lanyard or whatever you may be using for this name tag to go. So we're going to sketch on that face, and we're going to use an ellipse. You can use anything you want, but I'll be using an ellipse today. We're going to center it, and then we're going to choose a size. Okay, that's the size I want. Finally, we're going to click the check, and then we're going to go back to the extrude button, click the piece we want to extrude, go to remove, and then this time we want to do through all, because we want it to go through the whole entire piece. Okay, so there you have it. This is the name tag. So another thing you can do is if you make a piece for your robot or such, you can put it in assembly to put it in the robot assembly that you want. So you can go to assembly, click insert, and then there's a current document. So the part studio is part of this document. So you click the part and then click where you want to drop it. And there you go. This is how to do it on Part Studio for the name tag.